Okay, so we are here again. Mass 209. Mass 209. 209. Yeah. What we have here is more on forward difference and alternate notation. More on forward difference and what we call the alternate notations. The alternate notation. And so there is a question here for us, the photo based question. It said by constructing a forward difference table and taking the second order difference as constant. It said find the sixth term of 8, 12, 19, 29, and 42. 8, 12, 19, 29, and 42. So how do we do that? So we say let solution, we say let k be the sixth term. Since we're finding the sixth term, so let k be the sixth term. Let k be the sixth term of the series. Let k be the sixth term of the series. So what will be the difference table? We have x here. What is x? What are the values of x? We have 8, we have 12, we have 19, we have 29. Okay, no, sorry. Sixth term. So the values of x will be 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. What will be the values of y since the sixth term? So we are dealing with y here. So this is the first term. The second term will be 12. The third term will be 19. The fourth term will be 29. The fifth term will be 42. And the sixth term we don't know. So that's k. The sixth term that we don't know is k. And so what would be the forward difference of y? So 12 minus 8 is 4. 19 minus 12 is 7, I believe. 29 minus this is 10. 42 minus 29. 42 minus 29 is 13. Yeah. And then we have k minus 42. So we're just going to write that here. K minus 42. Now for here we have the forward difference squared of y. So 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3. So the next thing we're supposed to write here is 4 minus 42, k minus 42 minus 13. Did you see that? So we have k minus 42 minus 13. But the question says by constructing a forward difference table and taking the second order difference. So this is the second order difference. Taking the second order difference as constant. So what we believe is that everything on this particular segment of the table, on this particular edge of the table, everything here is constant, right? So we have 3, we have 3, we have 3. We are supposed to have 3 here. So since we're not having 3 here, we are equating whatever we see here to be 3. So we have k minus 42 minus 13 is equals to 3. Why are we doing this? They said you should take the second order difference as constant. Alright? So we have k minus 55 equals 3. And then we have k equals 3 plus 55. So your value for k is 58. The value for k is 58. Alright? So this is a direct sample that gives us an edge and a vivid understanding of how a forward difference table should work. Alright? And so from here we have no other option than to move to what is called the alternate notations. The alternate notations. The alternate notations. Alternate notations. Is that correct? All right. So what can we say about the alternate notation? We said let the function y equals f of x be given at equal space. Did you see that? Of independent variable system. Independent variable x, comma, says, let's say at x equals a, so our next term, comma, a plus h, comma, a plus 2h. So let me not bore you about what I'm just writing. We're just trying to say that if there's an equal distance between these intervals, right, at equal space of independent variable, it means that the forward difference of a will be f of a plus h minus f of a. So in mass 209, h, the word h is called interval of differencing. The word h is called interval of differencing. So let's assume that where we are starting from is f of a. The next person will be f of a plus h. The next person will be f of a plus 2h. The next person will be f of a plus 3h as we approach infinity, right? So what I'm saying is, what is the forward difference of f of a? Again, where we are going to, did you see that? Where we are going to minus where we are coming from. So we say f of a plus h minus f of a. Right? The forward difference of a is f of a. So if I ask you, what is the forward difference of a plus h? You would have told me f of a plus 2h minus f of a plus h, right? Is that clear? And so now that we have been able to understand this, it is now right, it is very right for us to go deeper. So let's attempt some questions on alternate notations. Let's attempt some questions on alternate notations. The first question, question number one says, it says, we should solve this problem. The forward difference of e to the power of ax. The forward difference of e to the power of ax. And so what do? Remember, we are only diluting. Let me write that out. In questions like this, we are only diluting x. In questions like this, we are only diluting x. So when I say the forward difference to the power of ax, what I actually mean is the forward difference of e to the power of a into bracket x plus h, right? E to the power of x plus h minus, no, sorry, let's do that again. It's a mistake. So what I mean, recall that the forward difference of x, for example, or f of x, let's put it, the forward difference of f of x is f of x plus h minus f of x. Let's not forget this definition. So it means that the forward difference the forward difference of e to the power of ax is e to the power of ax plus h minus e to the power of ax itself. Alright, I'm only diluting x. In the questions like this, you're only diluting x. And so we discovered that from here, what we're going to be having is eax plus, we are opening brackets, right? A times x, ax, a times h, ah, minus, did you see that? Minus e to the power of ax. And so this tells us about the law of indices, right? The law of indices states that this can be written as this, multiplied by e to the power of ah minus e to the power of ax. Is that correct? Alternate notations. And so from here, what is common to both sides? E to the power of ax is common to both sides, and so we write e to the power of ax into the bracket of e to the power of ah minus 1. Did you see that? So our answer is this. This loosely translates to the forward difference of e to the power of ax. Is that clear? Now that we have been able to have a basic knowledge on alternate notation, it is wise for us to dig deeper and ask ourselves more very important questions. Okay, let's look at an example. Let's look at an example again together. Let's look at an example together. Question 2. Question 2. We have the forward difference squared. Forward difference squared of e to the power of x. The forward difference squared of e to the power of x. And so we know that this is likely to be the forward difference multiplied by the forward difference of e to the power of x. So let's find the definition of this. We have the forward difference multiplied by, what is the forward difference of e to the power of x? You have e to the power of x plus h minus e to the power of x itself. Remember, where we are going to minus where we are coming from. And so if I have a number line like this place is e to the power of x, this person is e to the power of x plus h, this person is e to the power of x plus 2h. So we know that where we are going to minus where we are coming from, right? And so we have it like this. Now let's open brackets together. Let's open brackets together. This is forward difference e to the power of x plus h minus the forward difference of e to the power of x. Is that correct? And so now that we have been able to have it like this, then we can express ourselves and say e to the power of x plus 2h minus e to the power of x plus h minus, so what is the forward difference of these? This is e to the power of x plus h minus e to the power of x itself, right? So we have e to the power of x, multiplied by e to the power of 2h, bring that down, multiplied by the laws of indices allows this, right? Minus, this is 2e to the power of x plus h minus e to the power of x. Is that correct? So, having said that, we can now say e to the power of x multiplied by e to the power of 2h minus 2 times e to the power of x multiplied by e to the power of h minus e to the power of x. Did you see that? So, what is common to all sides? What is common to everybody? This is common, this is common. So we have e to the power of x into the brackets, right, of e to the power of 2h minus 2 e to the power of h minus 1. Did you see that? Right? And so this is the factorization. This is an expansion, right? It can be expressed as e to the power of h minus 1. So we say that, recall, and we clean this part, yes. We said recall that e to the power of h minus 1 all squared is the same thing as e to the power of 2h minus 2e to the power of h minus 1. Is that correct? Yeah. So we can then say that this expression e to the power of x into bracket e to the power of 2h minus 2e to the power of h minus 1 can be written as e to the power of x into bracket e to the power of h minus 1 all squared. Did you see that? So this is what we know as alternate notation, right? So in the short videos that we have done so far, we've been able to learn about this operator, the symbol, the forward difference operator, We've been able to learn how to construct a difference table with it, yeah, and we've been able to learn about alternate notations, right? Okay, all right, see you in the next class.